Hello, this is Ms. DB, and today we are going to look at some special systems where we might get different kinds of answers when we solve our system of linear equations. We will also learn to classify systems that have these different kinds of answers and determine how many solutions they will have. So when we graphed lines, we saw that when two lines intersect at a point, there's exactly one solution to a system. If they have at least one solution, they're called consistent. Sometimes when you graph two lines, you get parallel lines. They will never intersect. There is no ordered pairs that satisfy both equations because they never intersect, so there's no solution. A system that has no solutions is called an inconsistent system. We can also further classify consistent systems as either independent, meaning they cross in exactly one point, or a dependent system, which has infinitely many solutions. All right, let's look at the graph of each of these. All right, so here is the consistent and independent. They intersect at one point, and you can find a solution, either algebraically or graphically. If you have two parallel lines, we call this inconsistent. There is no solution. They will never intersect. And the third thing that can happen is that you have two lines graphed on top of each other. You can't even see that there's two lines here, but I graphed both of these equations, and they ended up being the exact same line. This is called a consistent dependent system. It does have at least one answer, one solution, but it actually has infinitely many solutions. Every point along these lines would be solutions because every point would work in both of those equations. So there's infinitely many solutions, and it's called consistent dependent. Those are the three types of systems of equations that we can have. This is a reminder of slope-intercept form of a line. If it's written in y equals mx plus b form, the m, the number in front of the x term, is the slope, and the number that's added or subtracted at the end is the y-intercept, just to review. All right, so here is a table summarizing all the different things all the types of systems of equations we can have. The first one, again, is consistent independent. That's when they intersect at one point, and that's the solution to the system. They will have one solution. Now, here's about the slopes and the y-intercepts. Their slopes will be different, have to be different. The y-intercept can either be the same or different. It doesn't matter. But the slopes must be different. That's very important. And the example for a solution is like a point, like 3, 5, or something like that. It'll be a coordinate point. Okay, we can also have two lines graphed on top of each other. That is called a consistent dependent. They will have infinitely many solutions. They have the same slope and the same y-intercept. Both of them are the same. When you're solving it algebraically, you won't be able to get an answer. You'll solve and you'll get down to something like 0 equals 0 or 4 equals 4. That's when you know that there are infinitely many solutions, which is what you would write for your answer on your paper. And finally, we might have inconsistent system where there is no solution. These have the same slope, must have the same slope, but different y-intercepts. Remember that if you have the same slope, you have parallel lines. So these have, when you try to solve it algebraically using substitution or elimination, you'll get a false statement like -2 equals 3 or 0 equals 5. And you won't be able to finish that either. And then you would write no solution on your paper. On your worksheet, the first three problems, you're going to be deciding what kind of system we have by whether it has same slopes or different slopes, and same intercept or different y-intercepts. So remember our different options again, and this is on your worksheet, so you can refer back to it. We can either have consistent, meaning there's at least one solution, and they can be independent, meaning that they have one solution, or dependent, meaning they have many solutions, or if they're parallel lines, same slope, different y-intercept, then they will be inconsistent. All right, so let's look at number 2. In number 2, we have the line y equals 2x plus 5 and y equals 5 plus 2x. So the first one is already written in slope-intercept form. We can see that the slope is 2 and that the y-intercept is 5. All right. The second one is not yet in slope-intercept form, so let me rewrite that. Put the x part first, that would be 2x, and then plus 5. So make sure they're written in y equals mx plus b form. So the slope is 2, and the y-intercept is 5. So now we look and we compare. Okay, they have the same slope. They have the same y-intercept. So if they have the same slope, same slope, same y-intercept, same slope, same y-intercept, then it is consistent, dependent, and they will have infinitely many solutions. So the type of system is consistent, dependent, and they will have infinitely many solutions. All right, let's look at an example of, let's just say that we want to figure out whether or not this has no solutions, infinitely many solutions, or one solution. Now, they tell us that it's going to have no solution, but how do we show that? First method is to compare the slopes and y-intercepts, but we can't do that unless it's written in y equals mx plus b form. So the first equation is already y equals 1x minus 4. We just need to put a 1 there. The second equation, though, we need to solve that for y. So I would have to add x to both sides, and then I would have y equals x, or 1x plus 3. Now that they are both written in slope-intercept form, we can compare the slopes. This has a slope of 1 and a y-intercept of negative 4. This one has a slope of 1 and a y-intercept of 3. So they have the same slope. If they have the same slope but different y-intercepts, that means that they're parallel lines. And parallel lines will never intersect, so they will have no solution. So one way of doing these problems is by looking at the slope and y-intercept. Another way is just to start solving algebraically. So let's see, to decide whether you should use substitution or elimination. It looks like it's already set up to do substitution because we already know that y is equal to x minus 4. So I can replace the y in the second equation with x minus 4. So I start to solve. I write negative x plus x minus 4 equals 3. And then I simplify, and negative x plus x is 0. Negative x plus x is not 1x. It's 0. They cancel, and I'm just left with negative 4. Negative 4 equals 3 is not true. That's a false statement. So that if you get to a false statement when you're solving with substitution or elimination, you answer no solution. There is no solution. Another way we could use to find this is we could graph the system, and this would be a good check. So when we graph the top one, y equals x minus 4, we get this purple line. And when we graph, this was y equals x plus 3, we get the red line. When we graph these, especially if we use Sketchpad or technology, we can see that these are parallel lines. They will never intersect, so there will be no solution. All right, let's look at an example where we might have more than one solution. So here's our two equations, y equals 3x plus 2 and 3x minus y plus 2 equals 0. Our first method is to write these both in slope-intercept form and check out the slopes and the y-intercepts. So the first equation is already written in slope-intercept form. The slope is 3 and the y-intercept is 2. The second one we need to first rewrite. So I want to solve for y. I'm going to add y to both sides. That's the easiest way. So I'd have 3x plus 2 equals y, and then if you want, you can rewrite that with the y on the left side if you prefer it, and you'd have y equals 3x plus 2. So the slope is 3, and the y-intercept is 2. They're the exact same thing. Y equals 3x plus 2, y equals 3x plus 2. They have the same slope and the same y-intercept. They will be the same line when graphed. Therefore, there's going to be infinitely many solutions. These would be consistent dependent graphs if you're asked to classify them, dependent, and there would be infinitely many solutions. You can also do these algebraically. So we already know that y is equal to 3x plus 2. It's already set up for substitution, so I will put that down here in the second equation. Or we could use elimination. Let's rewrite these, instead of using substitution again, let's rewrite these so that our terms are lining up on top of each other, and then check elimination. So I'm going to subtract the 3x from both sides of the first equation. So then I'd have y minus 3x equals 2. And then on the second equation, I could just rewrite this as negative y plus 3x, and I'll subtract the 2 to the other side. Okay, now I've got them lined up on top of each other, and I'm ready to use elimination to add them together because I see I have a 1y and a minus 1y. So I add 1y and minus 1y, and that's 0. And I add minus 3x plus 3x, and that's 0. So I get 0 is equal to 2 minus 2 is 0. I get 0 equals 0. Well, it is true that 0 equals 0. Which means that if you get a true statement, that there are infinitely many solutions. You could also graph that. Also, this is just a warning. 0 equals 0 is true. It does not mean that there's 0 solutions or no solutions. 0 equals 0 is a true statement, and there's infinitely many. We can also graph this system. Let's graph 3x plus 2. Y equals 3x plus 2. It's already set up. So the y-intercept is 2. The slope is 3, or 3 over 1. So from here I go up 3. 1, 2, 3, and over 1. And then I would draw that line. Okay, pretty close, right? All right, then I'm going to graph the other line, but first I have to get it in the right form. I'm going to add y to both sides, so I get 3x plus 2 equals y, or y equals 3x plus 2. So my y-intercept is 2, and my slope is 3 over 1, and you can see, I'll just dash this line. This is the same exact line on top of the red line. So they are the same line. So again, they are consistent, dependent, and there would be infinitely many solutions. Here's another summary of how many solutions you'll have and what will be true about their slopes and y-intercepts and what the graphs would look like and their classifications. That's in your textbook if you want to look that up or copy it. All right, let's say that we are going to classify this system and give the number of solutions. So we don't know if it's no solution, we don't know infinitely many, maybe it's one solution. We need to figure it out. You can try to do the method with the slope, find the slopes and find the y-intercepts, but in these, neither one are in slope-intercept form. So I think that's what they're doing. They're doing slope-intercept form. So they decided to write both of these in slope-intercept form, or to solve for y. And at that point, you would see that they have the same slope and the same y-intercept. And you would say then that they are the same line, it's consistent and dependent, and has infinitely many solutions. I guess that's the best way to do that one. It's not really set up for elimination or substitution at this point, although it could be. All right, let's look at this one. We have x plus y equals 5. And 4 plus y equals negative x. We could write that in slope-intercept form and compare the slope and y-intercept again. This one doesn't look bad to do with substitution, so we'll go ahead and think about that, but I'm going to solve the top equation for x just by subtracting y. So x would equal 5 minus y. And then in the second equation, where I see an x, I'm going to replace it with 5 minus y. So I'd have 4 plus y equals negative 5 minus y. The negative in front means I need to change the sign of each term inside the parentheses. So I have 4 plus y equals negative 5 plus y. Okay, now to complete solving this, I have a y on both sides, so I need to subtract y to get it together. And that leaves me with 4 on the left side equals negative 5. 4 is not equal to negative 5. When you come up with a false statement like that, you would say that there is no solution. And this is, since we're supposed to classify this, this is known as an inconsistent system. This would be an example where you have parallel lines. So the other method is to compare their slopes and their y-intercepts. These have the same slope and different y-intercepts, which means they're parallel, which means again that it's inconsistent and has no solutions. So remember that you can use either method. You can compare the slopes and the y-intercepts, or you can solve algebraically and find out what you get. All right, how should we do this one? Let's do this one by, first I'm going to simplify the top equation to y equals 4x plus 4. And then now that I know what y is, I'm going to use substitution and plug that into the bottom. So I'd have 4x plus 4 minus 3 equals x. So that's 4x plus 1 equals x. And now I'll subtract 4x from both sides, and I'll get 1 equals negative 3x, and divide by negative 3, and I get negative 1/3 for x. So I get a value for x. If you get a value for x, you're going to have one solution. There's just going to be one point where they cross. Let's look at the slopes and y-intercepts of these lines. If we set both of them up in slope-intercept form, we would have y equals 4x plus 4 and y equals 1x plus 3. This one you just have to add the 3 to. So they have different slopes and they have different y-intercepts. That method shows you the same thing, that they will intersect at one point and you'll be able to find the solution. Now my x value is a fraction, and that's okay. On your worksheets, you haven't had fractions, but that's just because I set them up so they'd be easier. It's not going to be too hard to find y here. If we use the second equation, y minus 3 equals negative 1/3, we would solve this by adding 3 to both sides. So y is equal to negative, y is equal to negative 1/3 plus 3, and that's the same as 3 minus 1/3, which would be 2 2/3. So you can find an answer if it's a consistent, independent system. On your worksheet, you're going to have several problems where you're going to be solving with either substitution or elimination and find out what you get and what that means. So if you get a false statement, then that means that you have no solutions and that you have an inconsistent system. If you get a true statement, that means that you have a consistent, dependent system, and that there'll be, why is it doing that? And that there will be no solution, infinitely many solutions, sorry. And if you get one solution, then it'll be consistent and independent, and it'll have one solution, and you'll be able to find that solution. Okay, so let's look at how to solve, if it lets me solve these. Get my pen here. Okay, so number 5, we have 3x plus 6 equals 6. 3x plus y equals 6, sorry, and y equals negative 3x plus 2. I think that I will use substitution, and I will substitute what y is into the second equation. I mean, what y from the second equation is back up into the first. So I have 3x plus y, and y is negative 3x plus 2. and that is equal to 6. So 3x, and then I have negative 3x, and then I have plus 2 equals 6. So 3x minus 3x is 0, so I get 2 equals 6. 2 equals 6, that is not true. So if I get a false statement, then that means that it is no solution. I get a false statement. False. And that means there is no solution, that these are parallel lines, and that they have, that this would be called an inconsistent system. So that's, I can say a lot about it just by knowing that 2 does not equal 6. Let's look at number 6. In number 6, we have that y is equal to negative x plus 3, so I'll put that down here. So x plus negative x plus 3 minus 3 equals 0. So I have x plus negative x, that's 0. And then I have 3 minus 3, that's 0. So I have 0 equals 0. That is a true statement. 0 is equal to 0. That means that this is the same line graphed twice. That's also called coincident lines. Same line. There will be infinitely many solutions. Infinitely many solutions. And finally, I could also say that this is a consistent dependent solution. So there's a lot you can say about these problems. Okay, one more to do. 3x minus y equals negative 2, and negative 2x plus y equals 3. Finally, I get to use elimination on one of these. This one is set up for elimination because I have minus 1y and plus 1y. So I can add these together. 3x minus 2x is 1x. The y's will cancel. I'll have 0 equals negative 2 plus 3 is 1. You could divide both sides by 1 if you want, but you're going to get x equals 1. And then I can go back and find y. I'm going to use the second equation, except every time I see an x, I'll put a 1. So negative 2 times 1 is negative 2. So plus 2, y is equal to 5. So I get a coordinate point as my answer. X is 1, y is 5. That means that I have intersecting lines. I have one solution, and they are called consistent and independent. So depending on what you get when you solve these, that will help you determine whether or not what kind of lines you have. And you'll also be able to tell what their classification is and how many solutions that they will have. All right, good luck. Have a wonderful day, and let me know if you have any questions. Thank you very much.